First thing I'm going to do is just go over the basics. So an amplifier like this is a voltage amplifier, takes a small signal and makes it into a larger signal. One of the things that's important to remember with amplifiers like this is that as they increase the signal itself, the frequency of the signal, so how often it goes up and down, stays exactly the same. So this has got a small amplitude, it's called, so a small height of wave. It's amplified a little bit and gets bigger, amplified a bit more and gets bigger. But the frequency, where the tops of the waves are, where the bottom of the waves are, or where it crosses the axis, all stay in exactly the same place. There are two different amplifiers that we're looking at the moment. One is a non-inverting amplifier, which we use as something called a preamp. So this might come after a microphone and before a power amplifier. And then there's an inverting amplifier, so one that inverts the signal, and that would be called a power amp. First of all, I'm going to look at a non-inverting amplifier. So this is something, like I said, that could be used as a preamp. And I'm going to look at the input signal here. So the input signal here, the voltage in goes up to 1 volt here. So it's going up and down to 1 volt. So for this amplifier, I want to work out what the output's going to look like. Now I know that the gain is 4 and this is going up to 1 volt here. So from everything that you've learned before, you should know that that means that the output is going to go up to 4 volts. So it will go from 1 volt input to a 4 volt output. I times the input by the gain and that gives me the output. Now I need to be able to draw the output from this system. So I know what the input is, I know what the gain is, and I'm going to draw the output. And the output looks like this. If you remember, the frequency doesn't change. So where it crosses the axis here, it's going to be the same. Where it crosses the axis here, it's in the same place. So I know these are two different graphs, but you can see that it's in the same place. This is a non-inverting amplifier. So what it means is the signal is exactly the same way up for the input and the output. So it's non-inverting. So when it's high here, it's going to be high on this graph. It's going to be 4 times as high. Gain equals 4. So my output here is going to be 2 squares in and 1 square up. I need to times that by 4. It's still going to be 2 squares in because the frequency stays the same. But the height is going to be now 4 times as much. So the gain is 4. So the top of my curve is now at 4. The signal that we're using, and you will always get this in an exam, will be an even signal like this. And it goes down to -1. So with a gain of 4, 4 times -1 is -4. So if I go down here, my output will be -1, 2, 3, 4. So my output is -4. Now, and this is a really important thing for you to be able to do in an exam. You need to be able to take an input signal and draw the output signal. It comes up time and time again in the exam, but also it's a useful thing for you to be able to do to show that you understand how gain works. One of the things you can see from this graph though is that this is only really going to work for us well with a small gain, because I've got a scale here that only goes up to 4 and a scale that goes up to 4. So if this gain is much larger than this, I'm going to need a really big graph down here. So what we tend to do is we change the scale of the voltage output graph. So if I look at a different problem, this is again, it's a non-inverting amplifier, and it's got a gain of 40, and I can see here it goes up to 2 and down to -2. I know that this frequency will stay the same, but I need to work out where it's going to go on the output graph. So the first thing I can do is I can work out what the maximum gain is supposed to be. So here I can see it goes up to 2. So I know that the gain on the output will be 2 times the gain, 40. So the output is going to be 80. So if this is 2 volts going in, it's going to be 80 volts coming out. Now this would mean that I would need a really big graph. It's going to take up half the page. But what I can do is I can adjust the scale on this axis of the graph. So if I start here at 0, I've got 1, 2, 3, 4, 5 there, and I want to go up to 80, so I'm going to make each square 20. 20, 40, 60, 80, and that'll be 100. Same down here, minus 20, minus 40, minus 60, minus 80, etc. So now I can easily transfer this input to a significant output. The first thing that I can do is I can find out where the key points are. So the key points are the top here, bottom here, and where it crosses the axes. So all these points here. And I can transfer them down. So I know that it's going to cross the axes here. It's going to cross the axes here, 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 and here. Now I know that this is a non-inverting amplifier, so I know that the signal here where it's high is going to be high on this graph, and I know this goes up to 2, it's a gain of 40, so it's going to go up to 80 on this graph here, so I know it's going to go there. I also know that at minus 2 times 40 it's going to go to minus 80, and I know it's going to be in line with this one, so down here. Now I can go and I can mark all these if I need to, but you'll find the more that you do this, the less you'll need to mark out these points, but they really do help. So my graph is going to look like this. Now you will find, not only in exams, but you will find for yourself that it is really easy, or it's much easier rather, to change your vertical scale here so that the graphs can fit on a decent piece of paper. Because obviously if I'm trying to do this that's a centimetre or so big, then I would need 80 centimetres down here, which is going to be bigger than my page. So you should change your scale down here. So what I'd like you to do now is there's an exercise for you to do with curves going into a non-inverting amplifier, and I'd like you to do the curves for the output for the non-inverting amplifier. Now you might be lucky enough at home to have a printer to print out my original graphs here, and then to be able to work on the answers below. But there's a good chance that you don't have a way of printing this out. Someone else might be using the equipment, or you might not have a printer. So I'm going to show you how you can answer the questions that I've set you without needing a printer to print out the worksheets. So on a question like this, I might have given you, or an exam board might have given you, that the input signal is going from 2 to minus 2 here, and that you've got a gain maybe of something like 40. So the first thing I would do is I'd work out how high I actually want my waves for the output to go. So that would be output would equal the input, 2, times the gain, 40. So I know that my output must be 80. Now that's nice and easy. If I can print this out, I can do 20, 40, 60, 80 maybe, and I can put my wave on here. However, not everyone's going to be able to print these out, so I'm going to show you really quickly how on plain paper or lined paper you could draw the output graph and send it back to me. So for me to be able to see that you understand how this works, there are two things that I need to be able to assess. I need to be able to see that you understand that the frequency stays the same, so these points all stay the same, And then I need to be able to see that you understand how high the output signal goes. If I'm given this graph, I'm going to draw it out here on my answer sheet, and I'm going to draw myself a pair of axes really quickly. So that's fairly easy to do. And I know that the input's 2, which I can put here, and -2 there. I'm then going to copy the graph on here. So I know that that's how the question is stated. Now I need to show my answer. So I've got my graph here that I've drawn, and I'm going to draw very quickly, I'm going to draw my output graph. I'm going to draw my answer down here. So I'm going to draw another set of axes on there like that. And the one thing that I know that I need to be able to show is that the frequency stays the same. So I'm going to draw some very light lines first of all where it crosses the axes. So I know that for my answer that my wave will cross the axes at these points. Then I need to work out if it's what kind of graph it is, if it's inverting or non-inverting. This is non-inverting that we're looking at first of all. So it's going to stay the same way round. Where there's a high point here, there'll be a high point down at the bottom. So I'm going to just quickly draw where all the high and low points should be, like this. And again, you can see I'm not doing it really accurately at the moment. I'm just looking to find out that you understand how an input wave changes to an output wave. So non-inverting, and I know that if I look back at this, I know that the output's going to be at 80. So what I'm going to do first of all is I'm going to draw my graph back in. So I know it's got to go up to this point here, through this point here, down, up, and I know if I go on the right bits here like that, so I've not quite done that well, but I know that I've got these points here and this point down here, and that I've matched up where it crosses the axes. Now if I was an examiner marking it, the first thing that I would look at, so non-inverting amplifier, I've got the wave in the same format as the wave that comes in. So this is V in, V out. Excellent, that's one mark. Next thing I would look at, have I got the points where it crosses the axes in the same place? Yes, I have, so that would be a second mark. The next thing that I would look at is, have I got the peaks and troughs at the right place on the graph? Now, because you're drawing this without graph paper, on a plain sheet of paper or a line piece of paper, all I'm going to do is I'm going to use my ruler like this, and I'm going to put the peak and the trough on there. So I know, if you remember from before, from this bit here, that the peak and the trough should be at 80 and -80. So if I put 80 on there and -80 there, that is good enough for me to be able to see that you understand that the frequency stays the same and that the gain shows a multitude here, so a multiplier here from 2 to 80. That would gain you a mark, and the fact that this is non-inverting, so it stays the same way round. Or if we see later on an inverting, it would go the other way round. So if you can't print these sheets out, it's a really good idea to draw your own graphs in this way, and that would be a really good thing for you to send back to me if you can photograph them.